Git is a software tool for systematically tracking versions of project files as they evolve over time. This video introduces many of the important Git concepts and how they fit into the Git landscape. However, this is not a how to use Git tutorial. It does not teach the Git syntax. Instead, it prepares you for learning Git usage from other more detailed tutorials. Let's start with basic concepts you need for version controlling your own files in your own computer. Let's say you want to use Git to version control a bunch of files in a directory. To do that, we should first ask Git to initialize this directory as a repository. The repository is where Git keeps version history database. Repo is the short name for repository. Note that these are not Git commands. They are the Git concepts that are being used. The corresponding commands are sometimes named after the concept, but not always. When initializing a repo, Git creates a new subdirectory to keep the version history database. Currently Git is not tracking any of the files. We can ask Git to ignore certain files if we are not interested in tracking their versions. Next, we ask Git to take a copy of the files we want to track. This is called staging or adding. A copy of each file is created in the staging area inside the Git directory. At the same time, Git starts tracking the staged files. Now we can ask Git to commit the staged copies into the version history. Committing is like taking a snapshot of the staged files so that we can restore the current state of the files anytime later. This object containing the copies of the staged files is called a revision or a commit. Next, we have modified two more files. To take a snapshot of the current state of the directory, we have to stage the modified files and commit them. Now we have two commits. The first commit is considered the parent of the second commit. Git keeps track of this relationship between the two commits. Now, we have modified another file. We can use the diff feature to compare file versions. In this case, we are comparing the modified file to its previous version. Let's modify one more file. Let's delete this file as well. In addition to staging these two files, we should also ask Git not to track this file anymore. This is the situation after committing. For ease of reference, we can tag a commit with a meaningful label. To restore the working directory to the state it was in when the first commit was created, we simply check out the first commit. Checking out the second commit brings the working directory to the state it was at the time of the second commit. Checking out the latest commit gives the latest version of the files. Note how Git saves only the modified files in each commit. To restore the working directory to a particular commit, Git might have to use file copies from more than one commit. Let's say you are working on this file. It is not fully done yet and you are not yet ready to commit it. What if there is a need to check out V1.1, which could potentially overwrite the changes you have done to the file? In this case, you can stash the changes first, which will take a copy of changed files to a temporary location and restore the file to its previous state. After that, you can check out the V1.1 like this. After you are done with V1.1, you can bring back the latest version and restore the stashed changes anytime. Now, let's move to more advanced concepts useful when using Git to version control project files while working in a team. When working in a team project, you can share your modifications with others using a remote Git server. After setting up a remote repo in the Git server, you can push the version history in your local repo to that remote repo. As you create more commits, you can push them to the remote repo anytime you wish to share them with others. Now, another team member can clone your repo in their own computer. The clone operation does several things. First, it creates a local repo in her computer. Then, it copies the version history from the remote repo to the new local repo. Finally, it checks out the latest version of the code into the working directory. You can use the fetch operation to download newer commits pushed to the remote repo by others. If you use the pull operation instead, Git downloads newer commits just like when you fetched, but in addition, it will try to update your working code to the latest version. Assume this user created a new commit. It can be pushed to the remote repo so that it is available for others to pull. In fact, you can push and pull from multiple remote repositories, sharing code with others in ad hoc ways. This way of managing versions among a team is called distributed revision control. You can use Git in a centralized way too, by getting all team members to use a single remote repo. Now, consider the sequence of commits. They are a sequence of nodes connected by edges, forming a branch. In a complex project, the version history can form a complex graph having multiple branches. Branches indicates code evolving in parallel for a while and merging together at some point. Imagine we are now at this point and we want to create a new branch to implement a new cool feature. We can start a new branch called cool feature. Git creates a branch label to keep track of this new branch. The sequence of commits you had so far has the default name master branch. Git uses a special label called head to keep track of the commit and the branch you are currently working in. Let's switch to the cool feature branch by doing a checkout of that branch. Now we have added a commit to the new branch. The branch label has moved to the latest commit automatically. The branch label attaches itself to the latest commit of that branch. Now, let's assume the feature is done and we are ready to merge it back to the master branch. We first switch to the master branch. Before we do anything, let's check if others have pushed new code to the remote repo. Note that the remote repo you work with is sometimes called the upstream repo. We usually use the alias origin to refer to the repo you cloned from. When you fetch from the remote, you find that someone else has added a commit to the master branch. Git uses remote branch labels to show you the current state of the corresponding branch in the remote repo. In this case, your working directory is one commit behind. You can check out master to update the working directory to the latest commit. That would also move the local head label to C4. Now we can merge the cool feature branch to the master branch. The merged code is added as a new commit in the master branch. That commit has two parents. The master branch label advances automatically. We can delete the cool feature branch if we want. Deleting a Git branch simply deletes the branch label, not the commits. To synchronize the remote repo, we can do a push. The remote branch label advances with the push. When merging branches, Git usually creates the merge commit automatically. Sometimes, a merge conflict can happen when the merging branches modified the same part of the code and Git cannot decide which modifications to keep. In such cases, we must manually specify how the code from the two branches are to merge. For example, we can decide to keep both changes. Let's go back to the situation before we merged. We are currently in the master branch and we are ready to merge the cool feature branch. When merging, instead of creating a merge commit like this, Git first tries to move the commits in the merging branch directly onto the target branch, like this. This is called fast forwarding, and it gives less complicated version graph than a normal merge. We can delete the branch label, as before. Rebase is an advanced feature for moving a branch from one location to another. Cherry picking can be used to pick only some commits of a branch. Squashing is used to combine multiple commits into a single commit. Rebase, cherry picking, and squashing are advanced features that change the version history. Those features are to be used with caution. That's it for this video. Next, you can try some Git commands in this online tutorial. To learn Git syntax in more details, we recommend resources such as this free online book. We used the free PowerPoint Labs add-in to create this video. We like GitHub and SourceTree too. Thank you for watching. Have fun with Git.